So hello everyone, this is lecture 33 for the quantum mechanics. In the today's lecture we will study about the finite square wave potential, and in the last lecture we studied about the infinite square wave potential. So first we will see the questions I have given you to solve. So in that first I gave you this, that for the symmetric distribution or the symmetric well, then how we are getting the two terms, that first is cos and second one is sine. But for the asymmetric one, when it was 0 to a, we were getting only the sine term. So how it was changed from that? So I have the solution for you. So it's kind of, now you see that only difference will be here, means you have the solution a sin kx plus b cos kx. After that you applied the boundary conditions for the asymmetric case. Now in the for the symmetric cases we will apply the same thing. This time we will say that phi will be 0 at x equal to minus a by 2, and phi will be 0 at x equal to plus a by 2, and we will apply that condition here. So on applying the conditions, we get these two solutions, means at minus a by 2, it will give you this, a sin ka by 2 equal to b cos ka by 2, means put phi x equal to 0 and this will give you this. At x equal to a by 2, this will give you this solution. So you have the two equations. Now adding these two equations, it will give you, this will give you 0, 2b cos ka by 2 equal to 0, and cos ka by 2 will be equal to 0 only when it is 2n plus 1 pi by 2. From here you can just 2 will cancel out and 2n plus 1 just take it as m. So it will give you k equal to m pi, and m can take only the odd values. So in the solution you will get cos term for all the odd values. So all odd eigenstates will give you cos term. So that's why you are getting here cos. Now similarly, in spite of adding, we just subtract them. So this subtract this equation from this, you will get 2a sin k by 2 equal to, this will be 0. So this time it will be like this, and now k by 2 equal to n pi to make this 0. Now from here k equal to 2n pi, and this time put this 2n equal to m, and m can be only even terms because this 2n will always give you even. That's why the solution for the even eigenstates will be sine, in terms of the sine. That's why you are getting sine here. So I hope it is clear to you now. Now let's discuss the questions I have given you. So first question was this: the wave function of a particle in an infinite loop square potential from 0 to a is this. So wave function was given 1 upon root 5 phi 1 x 2 phi 2 x. So you know these are the coefficients 1 phi 1 x and 2 phi 2 x, and phi 1 x phi 2 x is nothing but phi 1 x is root 2 by a sine pi x n pi, I mean pi x by a, and it will be sine 2 pi x by a, because the normal solution is nothing but under root 2 by a sine n pi x by a. So you know phi 1 and phi 2, so you can just write them here. So it will be this, and now you can plot them because the net solution will be superimposition of these two wave functions. So these two eigenstates. So we just plot first sign and the second sign, and that will give you the corresponding solution. So the solution will be kind this, means for the sine pi x by a, it will be 0 to a, this will be your curve for the sine pi x by a, and for the sine 2 pi x by a, this will be your curve. So that's how you will plot this. Now in the second part they asked us, find the time dependent wave function and its functional form at t equal to 2m a square pi h cut. So we need to find the time dependent wave function. For that we will use a formula I gave you for that. That is psi xt equal to exponential minus I h cap t by h cut. This is the Hamiltonian, the energy eigenstate. So it will be applied on the time independent wave function, and now we know the time independent wave function that is given to us. This is your time independent one. Now applying on this h will change to e1, and for this phi 2 it will change to e2. Now you know e1 and e2, and t is given to you. So we just calculate this term and this term. So exponential minus I e1 t by h cut will give you exponential minus iota pi, and the second will give you exponential minus iota 4 pi. Now see, you can just open it in terms of the cos and sine, means exponential I theta equal to nothing but cos theta plus I sine theta. So that will give you, this is nothing but cos pi, that is equal to minus 1, and this is nothing but cos 4 pi, that is equal to 1. So means this is equal to minus of this. So you can write this equal to this. So you can write both these terms in terms of the exponential minus iota pi, and just write it here. So we will write this term here, and in place of this term we will write exponential minus iota 4 pi. So now you can just write the phi 1 and phi 2 and these two terms, and this will be your function solution for this. So this is our next question, that is particle in infinite square potential, and the wave function is given under root 30x a minus x a to the power 5 by 2, where x is 0 to a, and we need to find the probability of finding the energy to be h cut square pi square 2m a square, and that means we need to find the probability of finding the particle inside the first state, because that is the n square is 1 square here. That's why to find the first state, we know how to write the wave function, that is in the sum of superposition of the individual हमारे that is wave functions. So it will be psi x is equal to c1 phi 1 plus c2 phi 2 plus c3 phi 3. So you know how to find the probability, that is given by c1 square divided by sum of all the c1 square plus c2 square plus c3 square. That's how you will get the probability for the first state. So we'll do the same thing. Now we know how to find the c1. C1 is given by phi 1 psi. So it will be phi 1, we know that is for the first state, and root 2 by a sin pi x by a, and psi x is already given, so we just take the inner product of these two. And inner product means we take the integration also. Now we just need to solve this integration and we'll get the answer. So I did the calculation, you can check this. If anywhere I am wrong, you can correct me. So in the last, I get this c1 as this under root 61 minus a by pi plus 4a by pi cube, and then probability will be c1 square, so the square of this will be this. So this is your probability to finding the particle in the first state or with this energy. So next question is, we need to find the expectation value of position and the momentum in this infinite square potential valve. So we just do the same thing. To find the expectation value of position, it will be psi star and x psi. So here this psi star will be given by under 2 by, means this is your psi. So just take the product of these two. So it will give you under 2 by a will square will give you 2 by a, and sine square n pi x by a, and the x. Now just need to solve this integration, and in the last you will get a by 2 as your expression value. So that is plausible solution, because we know that particle must be in meanwhile somewhere. So it is a by 2. Now to find the momentum, so we do the same procedure. Now we'll operate momentum inside. So it will be minus I h cut del psi by del x. So after taking the differentiation and after solving this, in the last we will get 0. So what is the meaning of this expression value of momentum is 0? Because we know in the square well potential, we know that standing waves are formed inside it. So standing waves are not moving anywhere. That's why we will just got this 0 momentum. Expression value of momentum is 0. Now next is we need to prove that x square is equal to this. So for that we just need to substitute in place of x. We will just do the x square here and do the integration. So this is the procedure. You can see the solution. In the last, you will get this a square 1 upon 3 minus 1 upon 2 n square pi square. So this is the same as we get here. We need to prove this. For the p square, there is something different. So I need to explain this. So psi star minus minus h cut square del square psi by del square. This is nothing but p square. So we know from the previous lectures that this is equal to nothing but e psi minus h cut square 2m del square psi by del x square. From here this 2m will go this side, and this remaining one will be nothing but 2me psi. So it will give you this 2me psi star psi, and now this will give you 1, and it will remaining will be 2m en. Now we know the value of en, that is n square pi square h cut square by 2m square. So this will cancel out, and you will get your this p square expression value as this. So this is the same as they asked us prove. So you'll get this. Now there is this uncertainty. We need to prove this, that this is equal to this. So how to find the uncertainty? So you know the formula for this also. Del x is nothing but under root x square average minus x average, and same for del p. So we know already find the value of x square and x. So we just substitute them, and the solution you will get the answer. Same for the del p. We will substitute the value, and you will get this. Now del x del p will be equal to this. So this is the solution. Now in the next question, you will get always you will get 1. As for the symmetric cases, you know there will be two solutions, that is odd and the even. So for the cos n pi x by a and the sin n pi x by a, so you will just do the same thing, phi star and phi. So take the inner product, and it will give you 1 always, just like this. So under 2 by a sin n pi x by a, under 2 by a sin x by a. So that is for the asymmetric case, that will give you 1 also, and for the cos also you will get the 1. So this the answer will be 1. Now the next question is, psi x is 0 equal to, means the wave function is given. So this is a superposition of these two eigenstate, that is first, third and the fifth, and their coefficients is also given. Now we know that how to find c1, c2, c3 here. See, I told you that wave function can be written in this form, and this is our given wave function. So we know that phi 1 is nothing but under 2 by a sin pi x by a. So we need to just compare them and find the value of c1, c2, c3. Oh sorry, c1, c3, c5, and then we can find the value of a. So how can you find that? So a by root a is nothing but c1 under root 2 by a, and that's how we'll find the c1 is nothing but a by root 2. And similarly we'll compare that this under root 3 by pi 5 is nothing but C3 under root 2 by a. So from here C3 will be this. Similarly, this 1 upon root 5a will be equal to C5 under root 2 by a. So this is equal to this. That's how C5, C3 and C1. Now we know that this is as a normalized wave function. So C1 square plus C3 square plus C5 square will be equal to 1. From here a square will be this and a will be under root 6 by 5. So now you can just find C1 also. C1 is a by root 2. So you know the value of a. So just substitute it here. And C1 will be under root 3 by 5. Now to find the expression value of energy. So there are three eigenstates. So it will be E1 PE1 plus E3 PE3, E5 PE5. You already know these formulas. We already studied them. So E1 you know in the first state this is your energy and probability is nothing but C1 square. So E3 will be C3 square, E5 will be C5 square. So this is your expression value of energy. Now the next question is potential is given as 0 for x 0 to a and infinite for otherwise. So the particle is in the ground state and the size of the potential value suddenly increases 4 times while moving RHS wall from 0a to 4a and where x is 0 is fixed. So how they are changing this? So they are changing it like it is 0 to a, now they are making it 0 to 4a and this changes becomes suddenly. That's why the reason for the suddenly means why we use the suddenly. So you will understand that. So what we need to find is what is the probability of finding the particle in the ground state of the new potential value and the first excited state. So when it was like this, so the ground state was nothing but phi 1 x is equal to root 2 by a sin pi x by a. But when it changed to this, so L is changed to 4a. So in place of a, we will write 4a. So that will give you 2 to 4. So it will give you 1 upon root 2a. So this is your changed, means a new ground state. Now you know how to find the probability. Take the inner product of these two. So inner product of these will be given by this. Now we take the limit as 0 to a. So here it comes that why it is suddenly, because if this change is suddenly, then you need to take the limit 0 to a. If this change was very slowly or you can say smoothly, then it will be 0 to 4a. So for the sudden change it will be 0 to a because particles most probability is still in the 0 to a. That's why we are taking it 0 to a. So we just take the inner product and this will be like this. So it is just simple integration and we'll solve this and the last you will get this is your probability under root 2 by pi 8 by 15. Now similarly you can do for the first excited state also, that will be under 2 by a sine 4 by x by a, and here it will be 1 upon root 2a and just you need to solve again, take the inner product and find the probability. That will be same. Now let's start our new topic, that is finite square well potential. So how it is different from the infinite one? So in the infinite one there will be 0 probability of finding the particle here and 0 will be here and there was infinite potential. But here this time the potential is finite, so the probability will be something like this. Means there will be also chances of presenting that particle here because of the tunneling and all. So that's why there will be difference. So the conditions will be V0 for x less than minus a by 2 and V0 for x greater than a by 2. And for the minus a by 2, a by 2, it will be 0. Means this is your potential given. Now there will be two cases we will discuss. First is the when energy is greater than V0 and second case is energy is less than V0. So for the greater than V0, it is simply scattering, means it is going infinite to infinite and there will be complete transmission, no reflection. So this will be your condition. So most our focus will be on the when energy is less than V0, but for the this case also we can write the problem. So in the classical case we can write the momentum also. So this time the momentum will be E minus V0, so it is 2m E minus V0. For the second reason it will be 2m E, and for the third reason it will be 2m E minus V0 for x greater than a by 2. So you can write this and in the quantum mechanically you can write also the solutions, that is phi 1 and the phi second and phi third. So similarly they are a exponential I k1x minus k1x. So this is a similar case as we discussed earlier. So you know what is k1 and k2 here. Now the what we need to actually study is the second case when energy is less than V0. There will be the most of the question can be asked from here. So let's see the second case. So in the second case, now this time we know the energy is less than V0. So it will be V0 minus E and equation will be changed to with minus sign here. So it will be minus k1 square phi 1. So now this minus sign will give us the solution in the which is independent of iota. So means here we are getting this iota, but in the solution of this equation we won't get any iota because of the differential equation solution, you know. Now for the second one it will be this, and for the third equation will be this. So now you have these three equations for the three reasons when the energy is less than V0. Now we can write a solution also. For the first one the solution will be a exponential k1x plus b exponential minus k1x. Now this term will be 0. Why? Because when the particle is here inside this, so there will be, when you go to the minus infinity, the probability of or the wave function must tends to 0 at the infinite. So at minus infinity, if you put, this will tends to 0, but this is still remaining. So at the minus infinity, x minus infinity, this whole term must be 0. So that's why this will be 0. And similarly, for this second reason, you will say that at plus infinity, this third solution must be tends to 0. So here is this third one. So again, at the plus infinity, so this will be 0, and still this is remaining, so this must be equal to 0. That's why this will become 0 at plus infinity, because at the infinity this particle's probability will be 0 or the wave function will be 0. That's why this thing and this thing will become 0 in the solutions. And for the second one, you know the solution that will be written in the cos and the sine terms. So we already discussed these solutions, how we write them, so I just repeated them again. So I hope you are clear about it. If you are still having doubt, you can put in the comment section. I will repeat that. Now what we will do now, we will do the boundary conditions again. We will apply the boundary conditions and find the solutions. So we know at x equal to minus a by 2, this phi 1 equal to must be equal to phi 2, and again the differentiation must be equal to the second differentiation, and also at the this boundary, that is a by 2, so this wave function must be equal to this, and the differentiation must be equal to the differentiation of second one, third one. So using these conditions on these three equations, you can solve them by yourself. There is nothing extra. So after solving them, we will get four equations because of these four conditions. So these four equations will be like this: a plus f exponential minus k1 a by 2 equal to 2c cos k2 a by 2, k1 a plus f exponential minus k1 a by 2 2 k2c sin k2 a by 2, a minus f 2d 2k2 d cos k2 a by 2. You know what is k1 k2 here, and af, all these coefficients. Now we will solve them. So first we will consider these two equations, and we will say that a plus f and c is not 0. If a plus f and c is not 0, then divide this equation by this equation and you will get this result: k2 tan k2 a by 2 equal to k1. Now if this is the condition, then this d must be equal to 0. So from here we get one condition. Now say we can, now this d equal to 0, then the equations here, this is already 0, this is already 0, now here d is 0, so the solution will be resolved to this cos term. So this is your solution now, and now see, you can see that this term is even term, so that's why this is, we call it as even function or symmetric. Okay, now we can use these other two equations. Now a minus f is not 0 and d is not 0, and divide this equation by this equation, you will get this as your solution: minus k2 cot k2 a by 2 equal to k1. Now to satisfy this condition, c must be equal to 0. If this is not 0, then c must be equal to 0. And now if you write c equal to 0 here, you will get sine term only. So the solution will be this kind, and you know sine term is odd term. So this is called the odd solution. So these are nothing but eigenstates. So you have the even eigenstates and the odd eigenstates. So you are getting both kind of eigenstates. So we can summarize them like this. So symmetric even solution will be this, and these will give you the energy eigenstates value for even state, because you know k2 is nothing but carrying the energy. So antisymmetric solution is odd solution. So you are getting two kind of solutions here for the eigenstates. And these equations, this one and this one, is called the transcendent equation. And what is the meaning of transcendent? Those equations which can't be solved directly, means by mathematically. So we can solve them only. These two equations can be solved by graphically or numerically. Numerically means hit and trial method. So equation 1 and 2 can't be solved directly. We can solve them either graphically or numerically. That's why we are calling that transcendent equations. So let's try to solve these equations. So let's put k2 means k1 a by 2 as alpha and k2 a by 2 as beta. So this will be alpha equal to beta 10. k2 a by 2 is beta, so it will be beta 10 beta. Now from the second equation, means just multiply with a by 2 here and a by 2 here, and also a by 2 here and a by 2 here. So second equation will give you, this equation will give you alpha equal to minus beta cot beta. So now you have these two equations, and you know what is alpha square plus beta square. Alpha and nothing but alpha is equal to minus k1 a by 2. It will give you k1 square a by square by 2. So beta square is nothing but k1 k2 a by 2. So it will give you k2 square a square by 2 2 square. So it will be this. So now from here, you know what is the k1 and k2. We already defined them: 2m v naught minus c by h cut square, 2m by h cut square. So this will resolve to this. Now let's call it whole term as r square. Then this alpha square plus beta square equal to r square. And this is the equation of circle. Now we can plot alpha and beta, and that will be a circle. And also there is these two equations. So is these three equations, if we try to put them graphically, then intersection of these three equations will give us the eigenstates or the eigenvalues of energy. So let's see how they can give us. So let's try to first plot these alpha equal to tan beta and alpha equal to minus cot beta. So this y-axis is alpha and this is beta. So for tan beta, how to get this curve. For 0 it will be 0, and for the 90 pi by 2 it will go to the infinity for the tan one, and also again pi to 3 by 2, and for these terms tan will be negative, that's why we are not taking that, we are just taking the positive terms. So here also it will go like this, and these dark ones are tan beta. Now we just need to plot the second one also, that alpha equal to minus beta cot beta. So see, this cot beta is negative here because this is pi by 2 to pi. This quadrant will give us negative cot value, but this already one negative is also there, so this will give you overall positive value. That's why this cot will be here. So we plotted them. Now we have this third equation, that is this alpha square plus beta square equal to r square. So just let's plot this circle also, and this circle will be like this, where this r is this. Now it is intersecting at this point. Now you will draw this second circle of second radius at this point and this point, so they are intersecting all these points. So what these points are, these are the eigenstates. How can we see them as eigenstates? Because r square is nothing but depending on the v naught. So this is your r square. So radius is depending on the potential. So for the different potentials you will get the different eigenstates. So let's say the potential is lying only between the 0 to pi by 2. Then what happens? You will get only one eigenstate because this is intersecting at this point. But if your potential is lying up to here, pi by 2 to pi, then you will see that you are getting two eigenstates. And for more high potential you will get three eigenstates. For more high potential you will get more eigenstates. So that's how you are getting the eigenstates. Now here they are intersecting. At that point you will get some value of beta, and beta is nothing but k2 a by 2. So this k2 is nothing but under 2me by h cut square. So from here you can find the value of energy eigenvalues because this is depending on the energy. Now see, for this first means r is lying between 0 to pi by 2, you are getting only one eigenstate. So if you try to plot this for v01 first potential, you are getting only one eigenstate. For the second one you are getting two eigenstates. For third one you are getting three eigenstates. So that's how they are increasing, means eigenstates are increasing with the potential because potential is depending on the r. Now see, if you reduce this r further and further and further, you always get one eigenstate. So there will be one eigenstate always inside the potential or the well. So if you need to find the how many eigenstates or the bound states you have, so you can find the relation also, one relation that for the 0 to pi by 2 there is let's see this, if r is lying between 0 to pi by 2, then the potential must be between this 0 and pi square h cut square by 2m square. This is the first eigen value of energy. So there is only one bound state for this one, and for the pi by 2 to pi, if it is r is lying between this, so you are getting two eigenstates for this, and for the pi to 3 by 2 you are getting three eigenstates. So relation will be simple, very simple. So it will be for the pi by 2 to pi you are getting 2, for 0 to pi by 2 you are getting 1. In general, for n bound state, this will be your solution. For this kind of thing you are getting n bound state. So generally they ask you to that how many eigenstates will be there. So if this kind of r is there, then there will be n bound state. So we can take and the potential will be, this implies that potential will be lying between this range because r is means v naught is depending on the r. Now let's say this is given, that's 16 and 25, and you need to find that how many bound states are there. So there's nothing but 4 square and the 5 square. So n minus 1 is 4, so n will be 5. So there will be five bound states if this potential is lying between this. So that's how you can find the total bound states. Now see, there are even and the odd bound states also. So there will be one even, and for the second one it is one even, second one is odd, then even odd even, even odd even odd even. That's how you will get. So there will be a simple relation for if n is even, then n by 2 there will be one even and one odd. But for if n is odd, then there will be n minus 1 by 2 odd eigenstates and n plus 1 by 2 are even eigenstates. So you can see here, if n is even means there is two eigenstates, then there will be 1 there will be equally divided. But when there is odd number of total number of states, that 3, so it will be 3 minus 1 divided by 2, it equal to odd states, and 3 plus 1 divided by 2 will give you 2 even states. So you can remember this formula to find the even and the odd eigenstates also. So I hope it is clear to you. If you are still having any doubt inside this, you can just put in the comment section. Now they also can ask you plot eigenfunction and the probability density. So for the n equal to 1, you will get only one, that is odd one. So see, for the first one is always even, then second one is even and odd, then third, fourth, third is even, odd, even. That's how it will go. So n equal to 1, it will be even state. So this will be your solution for the even. So now there is only cos term for 0 minus a by 2, a by 2, and it is increasing exponentially for less than a by 2, and for greater than a by 2 it is decreasing exponentially. So this will be like this, and for the minus a by 2, a by 2, it will be cos term for 0 to pi. So it will be something like this, peaking at the center. Now for the second one, it is odd eigenstate. So odd eigenstate, you know how to define, that is for the sine. So you will get sine curve like this, and at the center you will get 0, and here it will be decreasing exponentially, and here it will be like this. So that's how you will get the second state. And third state is again even. So you will get again for the cos for 0 to 3 pi by 2, means this is your solution. So this is again the even term, that's why you are getting this peak here. So again fourth one, that will be odd, and there you will get this asymmetric one. So that's how it will go on for the further states. So you must remember these plots for the starting ones. And if they ask you to plot the probability, so that will be the square of this. So we can just plot for n equal to 3, it will be like this. So that's how you can plot the probability also. So you must know how to plot these probabilities, and what are the eigenstates, and how they look like. So these structures are very important. Questions will be asked directly from them. So that's it for today. Thank you everyone.